Good morning, friends. Today we are going to discuss about energy of the spring, or in fact it is conservation of energy in case of spring forces. We all know that the energy is basically two types we consider. One we call it as a kinetic energy, which is because of velocity. Another form we consider it as a potential energy, and total of this one, kinetic plus potential, is mechanical energy, and mechanical energy is always constant. Let us talk about the energy of the spring. Consider first, this is the spring. In this one, it is a block here. It's O. Displacement here is equal to 0, and this is known as equilibrium position. Here, it is not stretched. It's at equilibrium. No net force is acting on this one. That is, the force acting here is 0. This is the case. Summation of all forces is equal to 0. Now, second case, what we are doing? We are slightly stretching it. It is a slightly stretch from here to here. This is slightly stretched. With a force, we stretch it and then we release. As soon as it is released, it will come back, pass through this point, it will come here and again move to and fro. So stretch the spring perform to and fro motion, which are known as vibrations. They start performing vibration. X is a displacement. And we all know, at this one, when it is passing, its speed increases. Here the speed V becomes maximum. Here it is a maximum speed, Vm. As it is going, speed goes on decreasing. Here V becomes 0. Again its speed increasing. It is maximum. As it goes here the speed becomes 0. So at extreme position, when x is equal to xm, velocity is 0. And when x is equal to 0, velocity is maximum. From this one, we can choose 2 points. Point O, this is a point O. This is point A. Let us talk about. Here, kinetic energy is potential energy at point. I am saying point O. Potential energy is equal to half kx square, but x is equal to 0. Potential energy is 0. At point O, potential energy is 0. Kinetic energy is half m v square, but v is equal to v max. So kinetic energy becomes m vm square. It is a kinetic energy. Total energy at this point, total energy is equal to v plus k, which becomes half m vm square. Vm is a maximum velocity by which the block can pass through main position. Maximum velocity is again at main position. Let us consider point O. Second is point O. Point A. Here, potential energy is equal to half kx square. X is equal to xm, which is equal to half k xm square. B. xm is the maximum displacement, which is also known as amplitude. Maximum displacement of the block or any object from its main position is known as amplitude. Now, kinetic energy is equal to half m v square, which is equal to 0, because velocity at extreme is equal to 0. Therefore, in this 2, at extreme position, at point A is equal to v plus k, which is equal to half k xm square. We all know spring force is a conservative force, therefore it obeys laws of conservation of energy. And at point O and point A, energy is same. So these two energies, this energy and this energy, we can equate them. Energy at O is equal to energy at half m Vm square is equal to half k xm square. M will remain as it is. This is cancelled. Vm square is equal to k by m x m square. Or Vm maximum velocity is equal to under root k by m x m square. This is the formula for maximum velocity. We know that k is called as force constant. F is equal to minus kx. Therefore, k is equal to f by x magnitude wise. So this one, force is mass. Force is equal to m1 L1 T minus 2. This is L1. So k dimensions are coming. These are the dimensions of force. These are the dimensions of meter. M1 L1 T minus 2 dimensions. So here we get dimension of k is equal to T minus 2. K dimensions are M1 T minus 2. K by M dimensions. K by M is equal to meter T minus 2 meter 1. So it is T. K by M, force constant per unit mass. Dimensions are T raised to minus 2 or under root K by M. Dimension will be minus 1. This is the dimension of frequency. K by M under root is a dimension of frequency, or M by K is T. We can take it. Time, or this one is known as omega. K by M, it's angular frequency. We call this thing as omega. So omega square is equal to K by M. Angular velocity or angular frequency, it is known as. Now we got it. Maximum velocity we got, angular frequency we got. From this one, we can show it here. That is, here Vm is equal to under root K by M xm square. This I am taking it as omega. So we get it Vm is equal to omega xm square. Omega is known as angular velocity. Now let us find out general case. What is the velocity at any point? Where? Any point P. Any point we are taking it. This is the spring. This is the block. This is mean position. Here it is xt, xm, and here it is x. General point we are taking it. Now here potential energy is equal to V half k x square. Kinetic energy is equal to k half m v square. Total energy is equal to point P. I am saying this is general point P. Total energy is equal to half k x square plus half m v square. But this energy is same as that of energy at point A. We can consider energy at point A. How much is energy at point A? Energy at point A is equal to half k xm square. So this is equal to energy at point A. EP is equal to EA. So half kx square plus half mv square is equal to half kxm square. Half will go, therefore kx square or kxm square minus kx square is equal to mv square. K is common. K xm square minus x mv square. K I can substitute here. What comes a K? Omega square by K is equal to, from here, K is equal to m omega square. M omega square x m square minus x square is equal to mv square. It is cancelled. So v square is equal to omega square x m square minus x square, or v is equal to plus or minus omega. V comes plus or minus omega under root x m square minus x square. And if you substitute this one here, then again it will come as a potential energy at E. So like that, from this one we can find out velocity also, or we found velocity also. Let us see the graph of total energy in case of spring force. What is a graph? It's a simple graph. If we see this one, it's a one reference line, origin. Now, potential energy, as it is going, potential energy it is increasing here. This graph, parabola, it is the potential energy. Here, x is equal to xm, x is equal to 0, x is equal to xm. Now kinetic energy. This is for V. Kinetic energy, it is here. It is K. So as potential energy increases, kinetic energy decreases. So here kinetic energy is 0, potential energy is half K xm square. To this side, potential energy is 0, kinetic energy is half m vm square. Similarly, here also kinetic energy is 0. Here it is potential energy is half k xm square. Kinetic energy and potential energy are complementary to each other. When kinetic energy decreases, potential energy keep on increasing, or vice versa, and thereby total energy of the block at any point due to spring force remains constant. We can say that in this case the law of conservation of energy holds good. That's all for this. Thank you.